I'm Kamal Aboul-Hosn. I'm the Uber tech lead at Google for our messaging products for PubSub and for Kafka. And so I have to admit, I am not a Beam expert by any stretch of the imagination, but I do know a little bit about streaming data. So I want to talk a little bit today about sort of taking a look at kind of where streaming data is and sort of how to think about it as you're working through streaming pipelines and trying to build these with all these systems that are available right now. So I really want to kind of take a holistic view of streaming. I want to step back a little bit and kind of not get deep into code or any technologies or anything like that, but just kind of look at it from a high level and really how to think about the decisions that you have to make when you're building these types of pipelines, and also talk about a little bit about some of the areas where streaming tends to be going, especially in areas of Kafka, for example. So what is streaming anyway? I mean, at the end of the day, we're just moving data from point A to point B. From a source to a sink, there may be many sources, there may be many sinks, but we are just kind of, carrier pigeons for data across wires, basically, and we're trying to kind of alter that data and do some things to it along the way as necessary. And there are a lot of ways to do this. Dataflow, Flink, Spark, Kafka Connect. There are a bunch of services within, say, Google Cloud or other cloud providers. And everybody loves to build and rebuild ways to move data. I have to admit, I am just as guilty of this, having worked on PubSub, Google Cloud PubSub, import and export, topics and subscriptions, and also single message transforms. So, and some people build their own DIY solutions as well. There's always a new way to move data from point A to point B and transform that data. And that's just always going to be the case. And I think this is something we really always need to keep in mind. There is never going to be one solution to rule them all. There are a bunch of solutions that come out and say, this is the final solution you will need for ever moving data from any place to any place. And as you dive in, there are different semantics, there are different trade-offs in terms of cost and these types of things. And really, I think that it's worth sort of moving one's thinking from the idea of there's one solution for everything that, I'm going to always use this one technology, to sort of the next level is, there's one solution per pipeline. So I'm building data that's moving from some source to some ultimate destination, maybe through some intermediary steps, but like I can do one solution for that entire pipeline and be consistent. All the way to moving to the notion of there's one solution per connection. So per kind of arrow, joining a source to a sink and choosing the best option for that individual piece. So life is always a bunch of trade-offs. And when we're thinking about streaming pipelines, a lot of these trade-offs are in terms of kind of latency, complexity versus cost. And, conventional wisdom with these types of diagrams is like choose two, right? Like you can always have two of them. But I think it's actually a little bit more complex than that. I think it's actually a spectrum where you're basically trying to choose a point within this triangle where you are trying to make trade-offs across these three dimensions, and you can sort of move, closer to one dimension if it's more important to you, but you're kind of still constrained by living within this triangle. And so, like I said, it's not a matter of choose two. It's really figure out what you're willing to trade off, and that decision may change based on the pipeline. It may change based on the sources and sinks. It may change over time as you're like, wow, like this pipeline is actually really expensive to run. Maybe I'm willing to make some changes to try to make it cheaper if I make, if I'm less latency sensitive, things like that. So it's also kind of a constantly moving target for our pipelines. And it really comes down to asking the right questions while you're building pipelines. And I think it's worth asking these questions every time you look at a pipeline. First off, where is the data coming from and where is it going to? This may inherently put some limitations on what tools you can use because you need the ones that can actually support where you're trying to move data from into. How much data? How fast do you need to move it? Are we talking, kilobytes a second or gigabytes a second? Everyone has a very different definition of what I have a large amount of data is. If I always say, don't trust anything that quotes in bytes or gigabytes per day, because once you break it down per second, it's very little. So thinking about how much this data actually is, And also, how fast do you need it to be there? Are we talking like, millisecond latencies or, hundreds of milliseconds latencies? Or are we like, 15 minutes or an hour is okay? So thinking about these types of questions of sort of fundamentally, how quickly do you need the data? And why might you prefer one tool over another? There is, I said, you want to choose the right tool for the job, but, familiarity with the tool can also be an important factor, right? If it's like, oh, I could use this other framework, but now I'm going to have to go spend the next 3 weeks learning about it and really optimizing it, you might say that, that is a cost trade-off in terms of your time and your efforts, and maybe that trade-off is not worth making. But it's worth considering, for if you sort of like have an opportunity to sort of expand your knowledge and use it in small places, there's an opportunity there. What do I need to do to the data? A very important question. The data is in some format in its source. You need it in some format in the sink. What do you do, and what do you really need to do to it? And when should you do it in the pipeline? We'll explore that in a little bit here. And also, who is the owner of the data? Now, I want to focus on these last 3 questions a little more. I think the first 3 are kind of a little bit more obvious to answer as far as, you know where your data is coming from and where it's going to, and you know how much data you have, and you know what tools you have. But these last 3 questions, I think, sort of become the very key of deciding, what tools to use for pipelines. And I think about pipelines in terms of data transformation. What do I need to do to the data as I move it from point A to point B? And I think about splitting this in terms of stateless transformation and stateful transformation. So stateless transformation are basically things you can do to individual records or messages as they move through the system. You may still need to reference data from another database. This would be sort of the enriched category, that last category on the stateless, where it's like I have some key that is in my message and I need to go fetch that data and enrich the message with that data. But it's still kind of like, as soon as you get to that point, you can throw that away, right? Like you can attach it to the message, you can keep going. Same with if you're trying to validate data or filter out based on pieces of the message or of the record. And if you're trying to alter, let's say you're trying to redact, private data, or you're trying to re-encode from like it came in as JSON, I want it as Avro or Parquet, or maybe you're projecting out fields you're like, there are a bunch of fields I don't need, so you're removing those fields. Stateful transformation is the things where you actually need to keep track of something locally within the pipeline, right? So this is deduping, right? If you're doing exactly once delivery and you really kind of need guaranteed exactly once. If you're doing ordered operations, especially if your source data is completely unordered and you're trying to put it in order, then you have to save records until you know you have them in order and then can spit them out in an ordered fashion. And likewise, if you're aggregating data, so if you're taking a bunch of records and you're summing over them or doing some work on them and then you're sending the results on, right? And stateful processing is inherently more complex than stateless processing. And so whenever you're thinking about this from, the pipelines you have to build, really ask yourself, like, do I really need to do this? Do I really need, if I'm building a pipeline, to have exactly once at the time of actually moving the data from the source of the sink? Does it really need to be in order? And, my experience has been that, we have systems that have these features built in, and you are trading things off here, right? This is complexity being traded off for latency in particular. And oftentimes when I dive in with customers or people who are building these pipelines and I say, why do you need it in order? And they're like, well, because it's usually it's easier to deal with. It's like, okay, well, what are you actually doing with it that you need the order? And oftentimes when you dive in, you'll find out you might not actually need that. And so minimizing the stateful transformations you need actually really helps with, kind of this trade-off equation. And, then the question is, okay, well, I have these transformations I know I need to do. When do I need to do them? So, there's this notion of ETL that's pretty common. That's where you're doing the transforms kind of on the way to the sink. There's ELT, where you're doing it on the way out. And then there's doing it before it gets in the source, which I don't think is a thing really named, so I called it T-E-L, just for purposes of this. So you're sort of doing it. So you can sort of do this at any point, right? And you may even have to do this, the decision may depend on, like, if you're moving the data to multiple places. If you're moving it to multiple sinks, then where you want to do this may change, right? So if I'm going to have an ETL pipeline, like if I have do I have two pipelines that's moving one data to each sink, and therefore I'm replicating that work? Do I have a single pipeline that outputs to two sinks? There are sort of the questions there of when to do it. Even if you're sort of wanting to stick to sort of ETL, you know, like ETL unfortunately has gotten a bit of a bad name these days. Everyone's like, ELT is the way to go now, because, you know, just dump the raw data and then do the transformation on the way out. And, you know, I think there is some kind of coming back around to ETL though at the same time, because it's like, well, if I do the transformations, that means I need to do them every time. Or I end up like, if I do ETL, and then I'm like, well, I need to save the result, like in a view, and I'm going to save that. And then it's, okay, well, now you're basically kind of doing ETL, just calling it ELT. So there's, you know, this ETL kind of gets a little bit of a bad rap, but I think, you know, there's still a lot of value in considering it, especially when we're looking at these kind of, you know, pipeline systems and systems, you know, and libraries like Beam. I mean, that's, you know, kind of its bread and butter is in that space. So, you know, the reason I say it's worth considering when to do things, you know, and kind of moving away from like there's one solution to rule them all, to thinking about it from even when to do things within a pipeline of like what are the steps where you can do things, right? You're not bound to doing all of the operations you have to do in one part, right? Like it's not like, okay, I'm going to use, you know, I believe ELT is the right thing to do, and I'm just going to do everything there, right? You can split this work up, and there may be advantages and disadvantages to doing different things at different times, right? If I think about filtering, for example, right? If I do it before the data comes in, it becomes cheaper because I don't have to move the unnecessary data beyond that point, right? If it's before it gets into the source, it's like, great, I've filtered it out, and now I don't have to pay for it in terms of compute or latency of even just like reading these records just to throw them away. But you know, you could have advantage of doing it, say, on the ELT side, because then you have the option to retroactively change your filtering, right? You could be like, I changed my mind, and actually I need to not filter out these records. Well, if you've thrown them out because you filtered them out before they got to the source, or you filtered them out in between as an ETL pipeline, like, unless you're going to go back and re-ingest all of the data, like it's gone, right? So you don't have that opportunity. So if you're not sure exactly how you're going to want to filter it, or your filtering is going to be more dynamic in nature, then filtering at the time of actually reading the data out may be the right thing to do. If you're trying to validate data, right, you're maintaining data integrity within your store of your data, whether it's your source or your sink. There can be advantages or disadvantages to doing it a different place. You know, if you do the validation before the data gets in, you could report the failure to the producer of the data, right? Which may be a good thing or a bad thing. Maybe you want them to know and you know, stop sending the bad data, like, you know, they made a code change and now it's just bad data, and you want to report it back to them. But you may also then be putting a burden on them, right, of like validating and making sure that the data is okay, and then having to respond to the fact that the data is not what was expected, and you're pushing that responsibility to them, which you may not even be able to do, right? You may not be able to tell them to go change their code. And so if you're going to do this later, you have to ask the question of what to do with invalid data, right? You either have to throw it away, or you have to sanitize it and fix it, which again, you may or may not be able to do. You can write it to a dead letter queue and then process it asynchronously later, figure out what to do with it. But you're going to have to figure out what to do with it, because, you know, there's always going to be a chance that there's invalid data. And it's probably important to even make sure you understand what your pipeline does in the face of invalid data, right? Always assume that, you know, bits can flip. And so making sure that you have a strategy to deal with the data that is bad is important. But if you're, you know, in a world now where we're trying, you know, there's a lot more of like, well, just put the raw data in a data source and then kind of do everything with it later. And that can be beneficial if you want to move quickly and just kind of get the data in there. But it means that you run a higher risk of there being bad data in the system. So understanding how to handle that and when to do it is important. You know, if you're trying to alter or enrich your data, there are different kind of advantages here. If you alter it on the way in, then those alterations were already done, and you don't have to do them again. And if you have, you know, if you're trying to send the data to multiple sinks with the same transformations, then you only have to do it at that very first time, and then you're good to go. Although you might find that doing it in the middle, sort of in the ETL phase, might be better because, in particular, now with a lot of AI models being used to enrich data that comes in, right? We're doing fraud detection by taking messages, running them through a model, and then getting back whether the request was legitimate or not, right? Like, you can only move data as fast as that enrichment piece can process it, right? And some of these AI pipelines can be, relatively slow on a message-by-message basis. And so you may want to control the rate at which that is happening. And ETL tends to be a good space to do that, especially, coming from someone who works on messaging systems and PubSub and Kafka, right? Like, this is their bread and butter, right? It's like, I want to be able to produce data very quickly and then let the data be consumed at the rate that the consumer can handle it, where in this case, consumer includes the system that is needing to enrich that data. So you can kind of build in those buffers inherently when you put this in the middle. The concern where if you do it in an ELT fashion is if you're enriching this data, you may have to just do it repeatedly, right? Every time you're running queries on this data, you're going to be like, okay, well, now I need to do the join and pull it out and do it again. You could then be like, well, I'll take this and write it then to a different view or a different table, but that's just ETL by a different name is really what it is. It's just you're deciding to do it kind of later. And, maybe you're like, I love writing SQL queries and SQL joins on my way out, and that's what my data analysts love to do, then you could do it. But again, you actually have to ask yourself, like, what are you paying for at that point? You could be paying for the extra storage if you decide to write it again, or you're paying for the compute to redo those computations over and over again. So, there's sort of a disadvantage there. Deduping and ordering, right? You may not be able to do this before the data comes in because you can't control what the downstream systems are capable of. On the flip side, if you do kind of these things on the ELT side, the advantage is, like, you can operate on a subset of the data, right? If you're filtering data, if your queries are always filtering out data, then you can kind of perform the ordering or deduping on that subset, which could save you some compute time of having to deal with that. ETL, it's kind of a mixed bag. Like, it depends on if the system, you're pulling data in from one place and writing it to another. So if you want to support exactly once or ordered semantics, you need your transformation system and your destination to support those operations on the writes into those systems. And so, it may work if those systems support it and you could do it. Again, you're now getting into those stateful transformations, so you have to ask yourself, are you willing to take the trade-offs of what could possibly be slower dumping of data into your sink ultimately? But if like, well, I only, I have 10 billion records in my data lake at the end of the day, and at any given time, I'm only going to fetch like 100 of them, and I can put them in order on the way out. Now your ordering operation becomes a lot smaller in nature. So thinking about when to perform that kind of stateful operation is important. And the same for aggregation. You can slow down the producer if you're aggregating data. If it's like, well, let the producer like pre-populate, like hold on to data in memory and then kind of spit out the result there. You could back up the producer system if you could even do it. Again, you can sort of view these a little bit as enrichment because you're taking a bunch of data and sort of smashing it together. The advantage is if you do it in ETL, you can process at the rate possible. But again, with ELT, you're going to have to do these repeatedly. So when you could do it, right? You could kind of do this all in the middle as an ETL pipeline and just kind of cobble on. But again, you can also think of this as the ability to split these things apart, right? If you have a system that allows you to transform the data on the way in or out, you can kind of do it on the fly. And then you can do things like the deduping, just using with the SQL queries on the way out. And so the other thing you have to consider is you may not have ownership of different parts of the system, right? Like if you were just like, the data is there, and like someone put the data and I need to take that data, you might not be able to control, what they do. So you may not actually be able to do anything with it. The same is true for the other side, right? Like you may not own the sink, right? You may have someone who's demanding like, you will put your data into my data sink. And so they may dictate what the format is and how the data looks, and you may just be subject to what they're doing. So you may not have control over that. And this kind of speaks to the question of who is the data owner, right? You can sort of break this down into two categories, right? Is this an operational workload that has data being consumed by an analyst? So, it's like, I have produced this data, and it is just part of my operational day-to-day working, and an analyst has come in and said, this data would be extremely useful to me, I want to use it, and then the operational workload is kind of the source of truth for the data, right? And the analytical data is what's following from it. Or it could be the opposite case, where it could be analytical data that you have to provide as the writer of an operational workload. So it's like, we have reporting requirements, and we need to know every time, this type of operation is performed. Here is the data sink where that needs to go, and here is the means by which you provide that data. And so understanding who is the source of truth for the data, and is it okay for there to be copies of the data? In other words, can we have I have my operational one, you have your analytical one, and we both operate independently, and then we're marshaling the data through? Or is it like the data can only exist in one place, either for regulatory purposes or just cost purposes? You don't want to pay for the data to be stored multiple times. Do transient copies of the data count? So publish subscribe systems, if it's something where it's just being used as a buffer to move the data, does that count as a copy of the data or not? And should all the stored data be valid? So this goes back to that point about when do you validate data? Is it okay to have invalid data that you sanitize on the way out as you're querying it, or is it required really that the data be valid from the beginning? And who defines that notion of validity is also important, right? Is it the person who is receiving the data, or is it the person who is the original producer of the data? So defining validity and understanding whose role that is kind of can help guide when to make these types of transformations or validations. So where is this all going? Well, we all seem to be heading towards iceberg these days. That seems to be our destination for everything. And right now there's a lot of work where you're kind of and this is sort of specifically thinking about Kafka, right? That with data lakes, you're dumping data in, and it's an ETL type notion of, well, we're going to use Kafka Connect or Dataflow or Flink or Spark, and I'm going to take data from Kafka as my data source and dump it into a data lake. There's this move now to kind of tie these things a little closer together, where it's Kafka can just be your data lake source and can have the metadata associated with it directly. This kind of works in some cases, but not all cases, right? If you think of the data lake as a sink, in other words, that sort of ETL notion, right? You have independent copies of the data, and this is a pull-based model where it's the pipeline is requesting data from, say, Kafka and pulling it in to the data lake. And it's kind of an accept first, clean later model, right? The data's in Kafka, I may have to sanitize it to get it into what my data lake wants. And this is more of an ETL model, right? There's now this kind of data lake as storage notion even for streaming data, where you can have a single copy of the data, assuming it doesn't need to be transformed. That's kind of a big caveat there. This is more of a push-based model. The producer is pushing the model into the data lake. This can make the producers aware of the issues they are having, but this really relies on ELT, or it's just kind of it's hidden ETL, because again, it's just kind of, as soon as you're taking that data and being well, I'm going to transform it and then write it back, and that's the data that I'm really querying on, then you're just doing ETL, let's be honest here. So there's kind of, this divide that's going in, this kind of new expanse of streaming data in particular, to think of streaming data as a source. So where does that leave us? Well, I am sorry to say I've probably left you with more questions than answers, and for that I apologize. But at the end of the day, transforming data is really inescapable, and I would say fine-grained decisions of when and how to transform data is really a better approach than coarse-grained decisions. And again, the data owner really becomes an important part of this question. So considering that is something to always consider.